All right, let's dive right into today's explainer. We're tackling a massive, high-stakes, and honestly, sometimes fiercely debated topic, choosing an enterprise tech stack. When a company picks the foundational technology for their core systems, they're not just picking a coding language. They are literally making a decision that dictates how fast they can scale, how tight their security is, and let's be real, what their IT budget is going to look like for the next 10 years. So we're going to use an objective, data-driven framework to cut through all the noise and hype to compare three absolute heavyweights in the industry: .NET, PHP, and Node.js.
Here's our roadmap for today's breakdown. We'll start with the enterprise application arena, then meet our three contenders, dive into a head-to-head comparison, look at the real total cost of ownership, and finally, figure out how to make a truly defensible decision.
Starting off with Section 1, the enterprise application arena. Because before we can even begin to compare these technologies, we have to establish exactly what arena we're operating in. Context is absolutely everything here.
Now, what's really fascinating is the hard, definitive line that separates your standard, everyday web development from true, heavy-duty enterprise application development. We aren't talking about a simple brochure website or a little side project. We are talking about massive systems that absolutely must survive intense, real-world production loads. These are the engines that manage incredibly complex workflows, integrated databases, and strict security requirements right out of the gate. In this arena, things like high availability and role-based authentication, they aren't optional upgrades. They are written into the spec from day one. To even step foot into this ring, a tech stack has to satisfy some pretty non-negotiable demands. Your system needs to be able to scale, handling more users and data without forcing you into a total rewrite. It has to hold up under sustained high concurrency performance loads. It absolutely needs built-in protections for security and compliance, long-term maintainability, and seamless cloud and DevOps compatibility. All three of our contenders today can pull this off, but as you'll see, they each achieve these goals in vastly different ways.
Moving on to Section 2, meet the three contenders. It's time to look objectively at both their superpowers and, just as importantly, their kryptonite.
First up, we've got .NET. You can think of this as the absolute powerhouse for large, highly regulated enterprises. Picture heavy actuarial calculations for an insurance company, or securing sensitive health records. Its major strength? Strong typing. It catches errors early. Plus, it has incredibly deep, native integration with the Microsoft ecosystem, like Azure and Active Directory, along with robust security tooling. But look at the limitations. It demands a slower, highly structured upfront investment. It's got a lot more initial complexity than lighter frameworks. And let's face it, hiring senior .NET developers with real enterprise experience can be a lot harder and much more expensive. Next up, PHP. Now, wait, before you say anything, we have to talk about modern PHP, version 8 and above. This is a totally different beast than that old PHP is just for personal blog stereotype from a decade ago. Today, modern PHP powers a huge share of massive, highly secure enterprise content and commerce systems. Its main strengths: lightning-fast structured development, a truly massive global talent pool, and it's incredibly cost-effective and cloud-agnostic. The catch, though, is that it requires rigorous team discipline. Without strong governance, you run a very real risk of accumulating some crippling technical debt over time. And finally, we have Node.js. Because it runs JavaScript or TypeScript on the server side, your front-end and back-end teams can actually share a single unified stack, which is brilliantly efficient. It uses an event-driven, non-blocking model, making it an absolute champion for real-time, high-concurrency workloads. We're talking live chat apps or heavy API polling. But its kryptonite is very real. Trying to do heavy CPU-intensive processing on its single-threaded loop, it's like trying to push a giant boulder uphill. Plus, the incredibly fast pace of the NPM ecosystem means you have to be super vigilant about dependency management, or you'll find yourself drowning in third-party updates. Section 3, the head-to-head comparison. Let's throw these three heavyweights into the ring together and pit them against each other. As you can see, your choice of stack immediately dictates your baseline capabilities. Look at the compute requirements. Notice how .NET totally dominates raw number crunching. If you're doing heavy processing, that's your guy. Node.js wins the real-time API race, hands down, with its crazy strong I/O concurrency. And PHP? It delivers exceptional, rapid development for web and commerce, and it scales beautifully when you pair it with solid caching. They all handle cloud deployment well, though .NET obviously has a massive edge if you're already living in the Azure ecosystem, while PHP and Node are totally cloud agnostic. But here's the critical realization we have to talk about. None of these is unconditionally faster. It's a huge myth. You can't just pick a stack and assume it's magically going to be lightning fast.
Speed and scalability are entirely dependent on your specific workload, whether you're compute-heavy or I/O-bound, and how well your engineering team implements things like caching, load balancing, and database optimization.
Moving to Section 4, Real Total Cost of Ownership. This is a major paradigm shift that every technical leader absolutely needs to grasp.
We really need to shift our anchor here. Too many teams get completely fixated on that initial build cost, just desperate to reach launch day. But to make a truly defensible enterprise decision, you've got to heavily weigh the brutal reality of the 10-year maintenance cost. It is a completely different ballgame.
Just look at this breakdown. Notice how that ongoing maintenance slice completely dominates the chart? It's by far the largest driver of total cost. The initial build is literally just a tiny fraction of the whole shebang. Over a decade, things like team seniority, integration complexity, cloud infrastructure, and compliance testing are going to completely dwarf your initial budget. For example, a stack that's super fast to build might end up costing a fortune to maintain if it requires constant patching or if your code quality slips over time.
Which brings us to a vital insight. The cheapest stack to build in is rarely the cheapest stack to run for 5 or 10 years. Think about it. A system built super fast in PHP or Node.js without strict coding standards is going to pile up technical debt like crazy. And unwinding that debt years down the line, it's vastly more expensive than if you just invested in a more structured, maybe slightly slower build up front with something like .NET. On the flip side, over-engineering a simple content platform in .NET means you're paying for a level of complexity you literally don't even need. And that brings us to Section 5, Making Your Defensible Decision. Let's pull all these pieces together into a practical framework.
If you work through these 4 specific steps before writing a single line of code, you completely transform a subjective preference into a defensive, rock-solid strategy. First, define the exact business problem and your realistic scale. Please don't build for Amazon scale if you don't actually need it. Second, map out your required integrations and security needs. Third, and this one is huge, assess the skills your team actually has right now. The question isn't just, are there developers in the market? It's, does my team have the experience to pull this off? And finally, calculate that 10-year total cost of ownership we just went over.
This brilliantly illustrates our ultimate takeaway. If any vendor tries to tell you their stack is the magical, universal answer, they're just trying to sell you something. A beautifully architected PHP system will easily run circles around a poorly architected .NET system, and vice versa. The stack is just your starting point, folks. It's the engineering discipline, the secure coding practices, and those foundational architecture decisions that actually determine if your application is going to survive in the wild. So as you gear up for your next massive enterprise build, I want to leave you with one final provocative question to ask yourself and your leadership team. Are you making a defensible architecture decision based on the true total cost of ownership and the hard realities of your workload? Or are you simply dressing up a personal preference for a specific coding language as a business strategy? Take a hard look at the data, align it with your business needs, and build something that's truly built to last. Thanks for joining me for this explainer, and we'll see you next time.